Hi ladies and gentlemen, this is Mr. Green and this is another in my series of lessons on geometry. Well, we're starting a new topic today. We're going to talk about circles and we're going to talk about lines and we're going to see what we can get into with some circles and lines and see what we get into here, okay? So, where should you all be? You should all be finishing up the Unit 3 unit exam, Part 1 and Part 2, making certain you get that turned in. Don't forget to make quiz corrections. Quiz and test corrections could make the difference in your whole grade. So make certain that you're looking at those and you're making the corrections you need to make and getting them turned in. Look at the corrections drop box over on the left-hand side of the page of the course. Make certain you understand how to make the corrections and get them turned in to me, okay? Due dates. We are approaching some dates where we'll be closing some things from Unit 1, and I don't want you to get stuck with zeros out there, so make certain you've got everything turned in you need to have turned in. Okay? So, we're looking at circles. Now, when we look at circles and we start drawing some lines on circles, we wind up with some things called some angles. And we give those angles some names. One of the names that we can call things are central angles. Central angles are any angles that are formed by line segments that go from the outside of the circle to the center of the circle and back out to the outside of the circle. So OPJ would be a central angle. Okay? Central angles have amazing things. The degree of the angle and the degree of the arc, which is the way we measure an arc, this degree of this arc, would be the same value. So that's going to be something that we're going to be able to use in what we're doing, is the degree of the angle and the degree of the central angle are the same. Okay? Another type of angle that we talk about when we talk about lines that we're drawing on here are called inscribed angles. Inscribed angles are inside of the triangle, or inside of the circle, but they start at one point on the circle and go to another point across the circle. This is a chord that goes across the circle, and then it goes from that point back to another point on the circle, another chord. So those two chords form together. This angle is actually 1/2 of this arc that's over here. 1/2. So the arc measurement and the angle measurement are related by a factor of 1/2. The angle is 1/2 the arc. Okay? I will get into that more as we go along here a little bit, but I just wanted to make certain I covered those and said those two very clearly to you. Okay? So here we go. Central angle. We're looking at this central angle. We've got an angle right here, A. We've got an arc, BC. If arc BC is 45 degrees, the rest of the circle is 315 degrees. Why? Because it's 360 degrees around a circle, right? Cool. So we've got a 45-degree arc right there. We've got a 45-degree angle right there. That's what that means. If you've got a 45-degree angle, you've got a 45-degree arc. They're equal to each other. Okay? So, this is one situation where we have an angle that is formed by two radiuses going through the center of the circle, and each one of the angles is 180 degrees. Special situation, we call that a semicircle. Why? It's half a circle. That's a semicircle. Okay? Terminology, it's all I'm trying to define for you here, is making certain you understand what these terms mean. Semicircle means half a circle. It means I've got two radiuses going across the circle that are dividing the circle in exact half. This angle is 180 degrees and this arc is 180 degrees. Okay? Now, the length of an arc. What we talk about the length of something, we're talking about how long it is. So they're wanting to know, how long is this line that I'm drawing on here? They want to know how long that is. We know how big the circle is because we've got this formula over here for circumference, 2 pi r. And what we're going to do is we're going to multiply this 2 pi r times the measure of the angle time divided by 360 degrees, because it's some portion of the entire circle. So you're going to take the measure of the angle divided by 360 times 2 pi r. It really is that simple. You take 2 pi r times and multiply that out, multiply it times the degree measurement of the angle, divide it by 360 degrees, and you get the length of that arc. Why is that important? Well, there are reasons why we want to know the length of that arc sometimes. Okay? Let's work an example. They say, what is L if the radius is 3? Well, let's see here. 2 times pi times 3, that's 6 pi. And let's see here. Do we know that degree of that measurement of that angle right there? What if we said that that measurement of that angle right there was 120 degrees? Okay? So what would we do? We would take this 6 pi, which is the entire circle, and we would multiply 6 pi times 120 divided by 360. Well, you know what? This turns out to be 3, and this is going to cancel out there, and I'm going to do a little bit of quick math here. 6 times 120 is 720 divided by 360 is 2 times pi, or 6.28 approximately. 2 pi or 6.28. That's what this length L would be. You guys see how I worked that out? I used the 2 pi times the radius, 3, 2 pi r. And then I used the degree measurement, 120 degrees of a full 360 degrees. Okay? So, chords and arc theorem. This is a theorem that says in a circle, in congruent circles, the arcs of congruent chords are congruent. What do they mean by that? Well, that means if I've got two circles, and in those circles I've got chords here, and the chords are equal to each other, then we can say that the length of RS will be equal to the length of DF. Okay? So, in a circle or incongruent circle, the chords of congruent arcs are congruent. Okay. This is I stopped there because I read it twice and I didn't read it the same way both times. The chord and arc theorem says the arcs of congruent chords are congruent, and the converse says the chords of congruent arcs are congruent. So this arc and this chord are kind of related to each other, and so they're just saying that either if the arcs are congruent, then the chords are congruent, and if the chords are congruent, then the arcs are congruent. That's what we're looking at there. Okay? So, I do appreciate you guys letting me know that you are what geometry course you're in and what section of the course you're in. So make certain you send me that information when you're sending me communications. It helps me find you and answer your questions a little bit quicker. Don't forget, I have tutoring on Tuesday, Wednesday, and Thursday, and I'm here to help you. Make certain you get in touch with me anytime you need me. I look forward to talking to you later.